so I give you 2 minutes to get these. I give you 2 minutes to grab these. Embarrass yourself. So there's a lot of stuff we can do with double and half angle formulas. We're gonna keep it kind of simple.
Are there more than exactly 5?
No, this is the last group I did.
In general, or that we're gonna learn?
So there's one style of problem for each. They're very similar. I'm going to give you one of the function values. Like here, I give you cosine of an angle is 3/5. And then I'm going to tell you something about where that angle is in the coordinate plane. So I'm telling you that sine is less than 0, so that means sine is negative. So here we go. We're taking stuff we knew previously and applying it to new situations there.
Yeah.
That's what math's all about.
Taxes are also
That's Bruce Clark. So I want to know sine.
Sine 2 theta or sine
Sine 2 theta. So we are going to the double angle identities. If you see sine or cosine or tangent 2 theta or like 2x or 2a, that's a double angle identity. There's 3 for cosine, 1 for tangent, 1 for sine. So I choose sine. So I want to know what the sine of 2 times the angle is.
Like what's A?
The A in our example is theta.
And that puts us in numbers?
So this is kind of a plug and chug. We know what cosine is, so we can plug it in. We need to figure out what sine is. Okay, so let me talk about why. And it's not this 4 or 5. Darius. So I have cosine. Cosine is x over r in our standard position angles in the coordinate plane. Sine is y over r. So we know that the denominator of sine is going to be 5 because it's the same as this guy. And so we find y by using the Pythagorean theorem. And eventually you'll get that y is 4. And of course, the easiest place to make a mistake is not having the correct sign, SIGN sign. We're told that sine of the angle is less than 0, so our sine value needs to be negative. And now I'm just multiplying. 2 times negative 4 times 3, 5 times 5. So what we're doing here is, if I have some angle in standard position, and I know that its cosine is 3/5, and then its sine value is negative, then we also know that the sine of 2 times that angle is negative 24 over 29. So we didn't even have to know the angle to figure out the sine of twice.
So you're literally just trying to, like, it's just small angle. Why does it matter? It's just small angle.
How do you know? This is not the angle. This is the relationship between twice the angle's y value and r value. It's not how big the angle is.
Okay.
It's a relationship between the sides of the right triangle it creates. Alright, so I'm keeping cosine equals 3/5. Sine is less than 0. I'll say that one more time. Cosine is still going to be 3/5. Sine is less than 0. I want you to find cosine of 2 theta.
So how do you know which cosine does it? Does it not use any of the three? Do you use any of the three?
We're back on. So there are 3 double angle identities for cosine. I say pick one. I don't care which one you use. I'm just going to choose this one.
1 minus 2 seconds. Don't pick the one I did.
Did you pick that one? No. Who picked that one? Okay, so for those of you who didn't pick that one, let's make sure we got the same answer. Because we should. So cosine is 3/5. So I gotta make sure I square that. Now the advantage to choosing this one would be if I just gave you cosine is 3/5, sine is less than 0, you wouldn't have to go ahead and figure out what sine was to use the other 2 identities. Just use this one. Cosine is 3/5.
I just looked at the first one, I was like, that's the one.
So why are there 3 formulas if you could just use any of them?
Minus 25. Your relationship. 20 minus 18 minus 25.
Like things complicated.
So 1 in 25ths is 25 25ths. So when I do 18 minus 25, I get negative 7 25ths. Reed, did you do it the same way I did? You got the same answer.
Cosine squared A minus sine squared A. That was what?
No. You didn't know, but he's doing it.
Okay. So I'll do it another way. Minus sine squared.
I've never done it. I'm assuming it's never done it. Hey, do you think send me something on it? Yes, I'm just gonna make a notification. No matter what it is.
So I get 9 over 25 minus negative 4 squared is positive 16. which gives me still negative 7.
So on a sine,
I don't know if it's mean or not.
negative 4 over 5, or is it always negative 4 over 5? Sine?
We found it in the previous problem. So I'm going to upload this video shortly. And, you know,
Everyone in the world knows how to think about
I think 5. Questions? What?
Like what do you
Double and half angle.
It's negative 4 over 5 because of 4 by 5.
All right, let's do a half angle identity problem.
How do you know?
So S is just another variable we're using to talk about an angle measure, like theta or X or A or B or alpha. So we're told that cosine of this angle S is 2 over 3. And S is in the 4th quadrant, which is why cosine is positive. Cosine is positive.
So wait, so it sounds like the thing says cosine is A over 2. Would it be 2/3 over 2?
S does not cosine does. So I have cosine of an angle divided by 2. Or I'm sorry, sine of an angle divided by 2. So that's a half angle identity. I'm cutting an angle in half. So I go find sine of A over 2. And instead of writing A, I'm going to write S because that's the variable we're using in this problem. It's an S. So we know what cosine is, so we can just plug it in. No. That would like get you some credit, but not all. Some, not as much as you'd want. Not as much as you should want to have.
It's not as much as you want.
Or maybe none. So we gotta simplify this. 1 minus 2/3 is 1/3.
So the answer is this or minus 0.16.
Yeah. And 1/3 divided by 2 is 1/6. And I'm not entirely happy with that just yet. Because the square root of 1 is 1. Still not happy. We get the square root out of the denominator. You all should be way used to that. And then I need to choose the plus or minus. Yeah. That'll get you almost all of it. So we need to decide which to choose, the positive root of 6 or the negative root. And we're in the fourth quadrant. Sine is related to y and r. In the fourth quadrant, y is negative, so we choose the negative root. So our final answer is negative root 6 over 6.
But in the fourth quadrant, isn't sine always positive because it's
Go in alphabetical order. Cosine, sine.
cosine x, sine y. Okay, everything. Not x,
Okay, so everybody listen. Cosine is still 2 over 3, and it's still in the fourth quadrant. I'll say that one more time. Cosine is still 2 over 3, and angle S is still in the fourth quadrant. Find cosine of S over 2.
I would probably.
How do you know it's positive?
cosine is positive.
This is the fourth quadrant.
Cosine represents x, right?
So I chose the only cosine half angle. I plugged in 2/3 where cosine S was. I simplified, and I chose the positive root because we're in the fourth quadrant, and in the fourth quadrant, cosine is positive. Root 5 times root 6. So to get rid of the root 6, I multiply the top and bottom by root 6. And then, all right.